Sharding.
To it. We're going to talk about sharding and extreme scalability, availability, tenancy, and sovereignty. So real briefly about me, I've been working with Oracle for about 25 years now, and I'm on the board of directors for for a regional user group here in the US, the Utah Oracle User Group, and then also the RAC Special Interest Group. And I've presented at Open World and Collaborate and multiple regional user groups across the US and Canada in person, and now because of COVID around the world. So I'm a principal consultant with Viscosity North America. Viscosity is a full service Oracle Platinum partner, and we're the 2019 Oracle Database Appliance Partner of the Year. And in my role, I help customers with rack and maximum availability architecture implementations with their engineered systems like Exadata and Database Appliance, and diagnostic tools, Autonomous Health Framework and Trace File Analyzer, RDA, and so forth. I have a really deep background as an operational DBA, database reliability engineer and architect, and I leverage that to build automation, particularly when it comes to upgrades and migrations and cloud implementations. So I was really happy to see Mike's little mention there at the end of his last presentation where he was talking about emphasizing the importance of automation. That rings true with me. I'm also an Oracle ACE, and if you're not familiar with the ACE program, it recognizes members of the Oracle community for technical contributions to Oracle technology. And if you or someone you know is active in the community, either as a presenter or blogger, or works behind the scenes, especially folks like the user group volunteers who put on events like this, I really encourage you to nominate them or yourself, and you can do that right down here. Oops. If I activate my highlighter, I suppose that you can do that right down here at this acenomination.oracle.com. And don't let pride get in your way. Feel free to nominate yourself. The nomination form is kind of difficult to do for other people sometimes. So on to the show. How this came about, a long time ago at a conference far, far away from here, I saw a presentation on sharding, and I thought that it looked like a really interesting technology, primarily because I enjoy building high availability systems and I like the challenge of distributed databases. I work with a lot of the other components of the maximum availability architecture, and sharding is part of that footprint. And I really like to work with new technologies and learn new things, and the concepts and the potential and so forth of sharding seemed really interesting, and it felt like a good match for me. And what I've learned in the past couple of years of looking at sharding and sharding solutions and so forth is that sharding is a very complicated subject. And I could spend probably 2 or 3 hours just going over the differences between the different sharding methods, and maybe another couple of hours to talk about topology in moderate detail. It is a really deep subject, and Oracle doesn't make it any easier with their marketing. Because if you've been to a presentation on sharding, especially an Oracle presentation, you will have probably seen slides like this. Slides where they're talking about how performance scales linearly. So if you look here, you see 3 million, just under 3 million transactions per second on 50 shards scales up to around 11 million transactions per second over 200 shards. You know, these are really big numbers. We're talking about scaling out to 200 shards on Oracle Cloud, 11 million transactions per second, 100 primary and 100 active standby, DataGuard standby shards, DataGuard fast start failover. I mean, these are all really neat technologies deployed on massive scale. We're talking about shard failure where a single shard failure gives you 99% availability of the remainder of the application, and that 1% saw a 15-second blackout period, or probably more likely a brownout because of the failover. Or, you know, putting it another way, a single shard out of 100 shards fails, you have 1% of your data or 1% of your customers are affected or experience slowness. And then you'll see slides like this as well, where we're talking about the organizations that are using sharding. And again, lots and lots of really impressive numbers, 65 billion transactions per day for telecom. And this is the list. You're going to see telecoms, you're going to see law enforcement, homeland security, stock exchanges are the organizations that are using sharding. And it's really easy. Oh, well, here, let me just show you this too. I tried to look at the specs for the benchmark that Oracle showed a little bit earlier, where they were talking about the 11 million transactions per second on 200 shards or 100 shards of active or active data guard. And I couldn't come up with exact numbers, but based on what I could find, you're probably looking at $3.4 million in cloud costs for that 200 shard configuration. Roughly speaking, I'm sure you can negotiate for a discount on that, but this is the kind of IT budget that we're probably looking at with that. And this is probably not you. It is probably not your environment. And if it were, if you were spending $4 million a month on IT budget just for your database, you wouldn't be in my session. You would be running this session because you probably know far more about sharding than I do. And I get it. These are really impressive numbers, and they're definitely something that Oracle should be bragging about. But I think that Oracle's marketing has just buried the lead a little bit on sharding, and namely in how it's used, because most of us don't need to scale horizontally out to 200 shards. We do not have the capability, most of us, to position our data across 100 separate sites, let alone manage that sort of deployment. So when you look at these customer case studies, the profile is not going to be the typical Oracle database shop. These organizations that they're highlighting are really on the margins, and that makes it really easy to look at sharding if you're on the outside and say, well, that's not a technology that really applies to what I do. It's really easy to dismiss it as something that Oracle has invented or put in place to deal with those extreme environments and those extreme requirements, or to be able to keep pace with a particular market trend or a certain customer, so they can say, well, yeah, we offer that too. But it turns out that scale and performance are not the only challenges that modern enterprises face. So one thing that a lot of us are beginning to see is the need to address regulation. If not now, then potentially soon. There are conventions that limit the countries or regions where sensitive data is stored. And those are on the rise thanks to privacy laws, courtesy of multiple repeated data breaches. So where data is stored and how data traverses networks, whether that data, whether that data can cross political borders and boundaries, and even what entities can gain access to data based on its location, are a new reality, and certainly a challenging one that we're facing. And then if you deliver services that are sensitive to latency, if you work in the gaming industry, if you have any sort of content delivery, if you're in a space that deals with virtual reality, you want to be assured that you're delivering data from locations within a given physical sphere where you can guarantee round trip times to your customers. So even if you're not facing that requirement that you legally must keep data within a region, you may just have a service requirement that mandates that. And finally, if you have a tiered delivery model where perhaps you have free customers, you have entry-level users that are on a base level paid account, and then you have premium users, and you want to be able to deliver those premium users a guaranteed performance and data availability and data durability service level, You want to be able to offer your entry-level users good performance and moderate availability, but not spend tons of money on their delivery, and be able to offer your free customers a service, but without any sort of performance or availability guarantee. Then you're looking at a tiered architecture like this, where you want to be able to locate those premium users' data physically on more robust hardware and infrastructure, locate those entry-level users on moderately protected, moderately available infrastructure, and then put those free customers on the less expensive option where you don't have to spend a lot of money guaranteeing availability or performance. So these are all far less maybe interesting problems, but they are really important problems for us to work with. And they're a lot more common, I think, than these matters of scale. And the common thread in all of these is a need to distribute data across multiple physical locations or hosts while maintaining the appearance of a single database when it comes to the application and clients. So we have much more overlap when we're looking at environments that have these problems where sharding may solve them, who are also here in this presentation, that don't need that high performance 200 node deployment. So this tenancy and sovereignty, tenancy and sovereignty, wow, can't talk, it's too early for me still. So sharding addresses the tenancy, sovereignty, proximity, tiering, privacy controls, ownership, and access to sensitive and protected data issues that we're dealing with. So getting into the actual technology itself, your objective for sharding is going to determine the sharding method. And in 19C, you have three options. They're system managed, composite, and user defined. And I should take a step back and note that sharding has been available since 12C, I think 12C R2, it's escaping me now, 12C R2. And in the ensuing versions, 18C and now into 19C, sharding has really matured. And so since we're learning about sharding in this presentation, I'm talking mainly about 19C. I'm not discussing any future features and feature sets beyond and this is going to be available to you in 20C and 21C and beyond. But really what I'm focusing on here are the features that are available to you in 19C, since any of us that are going to be looking at sharding as a solution are probably looking at a future implementation. So here in 19C, you have these three different sharding options. There's a system managed sharding, composite sharding, and user defined. And so with system managed, the sharding key is a consistent hash. It's system managed, and you get this massive scale and performance of your systems. And consistent hash or system managed or sharding is what was used in that earlier example that I showed you, where we were getting 11 million transactions per second. The downside, I suppose, if you want to call it a downside to system managed sharding, is you have no control over the data's location. So Oracle is going to assign a sharding key to that system managed shard, and it's going to distribute the data in pretty much a round robin sort of fashion, where it's balancing the amount of data on any particular shard, and you have no control whatsoever over where that goes. Next, you have this user-defined sharding, and in user-defined sharding, you're sharding by a value or a range. And the example that I'm going to follow through most of this presentation is based on geolocation, where we're talking about a North America set of customers, a European data set, and an Asia Pacific data set. And so here your value might be your region code or your country code. You can also shard, user-defined shard by range. And if this sounds like partitioning to you, just hang on because I don't want to spoil the surprise. With this user-defined method, you have complete control over the location of your data. So you can say, I want this data to go on this particular shard. And of course, you can locate that shard physically anywhere that you want. And the third option is composite sharding. And this is where you shard first by value or range, just like you have in the user-defined method. And then below that, you have that composite hash partitioning. I'm giving it away, aren't I? You have that composite hash sharding method. And this gives you top-level control of data location, where you say, I want all of my data to go into this general pool of shards or servers. And from there, that system managed sharding method is going to distribute data evenly within that, that set of hosts. So in my first draft of this presentation, way back, I tried to cover everything, all three of these methods. And it gets really ugly because system managed sharding has a set of unique terminology and constructs, and that falls over into the composite sharding method as well. And when you combine composite sharding, user sharding, and system managed sharding, you get this really confusing mess of terms and terminology and constructs. And it gets really time consuming as a presenter trying to fit something into 45 minutes to say, this is something that you use in this particular method, but not in that method. And here's this other thing that in this method works this way, but in that method works that way. And when you combine the two, it works completely differently. So rather than confusing you with lots of topics that probably aren't relevant, I'm going to concentrate solely on the user-defined method, which is probably the simplest way of doing this. This is the method that you would use to manage tenancy, and it fits the use case that we're looking at here, where we're looking at compliance, where we're looking at managing tiers of data and data proximity. And fortunately for us, it includes all of the most important concepts for sharding. And I feel like it's the best foundation for us to broaden understanding into the composite and system managed methods later on. It's also the most straightforward technique. So it's the easiest that you're going to deal with in a sharding situation. So again, it just uses a list or a range of values as the sharding key. And if you're already familiar with list or range-based partitioning, it's going to feel really, really comfortable for you, because sharding is just Oracle partitioning. And I'm not saying that as an analogy. I'm not trying to oversimplify sharding by any means. Sharding is absolutely just an extension of the same partitioning technology that's been part of Oracle for years. And when you consider it that way, you begin to realize that sharding isn't really a new product or a new concept that Oracle has invented. It's an existing technology, the partitioning technology, that has been extended out to cover not just partitioning tables physically into separate storage, but into partitioning data into separate databases. So for this example, I want you to imagine a very, very simple banking database. Here we've got some tables for customers. We've got a table for customer accounts. We've got a table for transactions. And then we have some relatively non-volatile tables here for our different currencies and our different exchange rates, say. And when you look at this database, you see that these tables, the customer account and transaction tables, these, if our database is getting really large, these are tables that are candidates for partitioning. So for argument's sake, let's say that our bank wants to partition data by the customer's geographic location. We'll break it down, like I said, into North America, Europe, and Asia Pacific. And so if you start looking at the database that way, you'll see that we've got this customers table, and it's got a North America partition and an EU partition, APAC, and the same thing for our accounts and transactions tables. So now we've got these tables and they're partitioned out. If you have a client that connects to the database, they see this as one table, even though we're physically storing this data in different partitions or different extents or different disk groups or whatever it may be. So let's take a step back here, and we now look and we see we've got our regions. We've got this North America region and its partitions for customers, accounts, and transactions. And all of our related data is co-located here in the same partition. So our North American customers, they're all in this North America partition. We're storing it in that North America partition. Maybe we've got a ASM disk group and we call it disk group North America. And we've got our disk group EU and our disk group APAC, if you'd like. And this is a traditional database with some partition tables. Probably looks relatively familiar to some or most or all of you. And this is the same database, but we've sharded it. And what sharding is horizontal partitioning. The difference between partitioning and sharding is the partitions that we were looking at before are now completely separate physical databases. None of these databases share any storage or hardware, or at least they don't have to. And we refer to this as a shared nothing design. It's why when you saw before that Oracle was saying in that kind of confusing slide that 1% of, or if one shard went down, 100% of the nodes had 99% availability or something really confusing like that. This is why if you have one shard go down, it doesn't affect the rest of the database. Because if our APAC database were to go down here, EU and North America are up and running and they see no outage to any of their data. We still have our reference partitions. So we've got this North America shard, we've got our EU shard with the parent and child records for all of those customers living there. The difference is that these are no longer separate partitions. They're part of a separate physical database. And since these are separate databases, we can move them into different physical locations. Now, if our database has records for EU residents that require data sovereignty, perhaps affected by GDRP, these records, we can physically locate them in a shard that lives in a compliant data center. And because every shard is independent, while remaining part of a single database, it can be accessed from a single application. So you don't have to worry about developing and deploying an application regionally for your EU customers and your APAC customers and your North America customers. It's just one application. It's the same as when you're dealing with partition data. Clients have no concept and no visibility into the physical structure of the data underneath it. It's just abstracted into a single physical entity. So all of this is transparent to our applications. And again, this allows us to address more than just our data residency. We can locate data close to customers, and we can address that latency issue, and we can tier data as well. So we can put some data into a very robust set of hardware, some data into a moderately robust set of hardware, and some data into cheap commodity hardware, because we don't really care if those customers experience an outage. So getting into some of the architecture of sharding, we've talked and we've discussed the fact that now we have 3 separate databases in our example. I want to introduce you to a couple more concepts that are peculiar to sharded databases. And the first of these is the catalog database. The catalog database is a separate database that is effectively a repository for the shard database schema. So this catalog database has all of the information about all of the tables that are here in these individual shards. So any kind of maintenance, any management, DDL, changes to the schemas and so forth, these are all performed on the shard catalog database itself, either through OEM Cloud Control or this tool called GDS CTL, or SQL Plus even. So GDS CTL is the global data services control. You can also access the shard catalog database. It's a regular Oracle database, so there's nothing particularly special about it. So you can access it through SQL Plus as well. So anytime you need to change DDL, you need to make a schema change or anything like that, you would work through your command line client or through Cloud Control, work on the catalog database, and then the catalog database propagates that change into all of the shard databases that it works with. The catalog database is also a hub for any reporting or queries that we need, where we're going to retrieve data across multiple shards. So if you think about it, if you're this bank and you want to know what your assets are and what your total deposits are and things like that, you can get it for these individual databases by going on to these individual systems. And they are available to you as individual databases as well. So you can go here and you can run reports on the North America database and so forth. But this North America database can't really see the EU database. So if you need to get information that spans all of your shards, that is achieved through this shard catalog database. So it's like a transaction coordinator in a sense, or if you think of NoSQL database, where you have distributed processing that occurs on each individual database, and it coalesces the results. That's your shard catalog. So I want to take a step back for just a second and look back at our original partitioned database. Remember, we had these partition table candidates, but we also had these common tables. These were our low volatility tables that were our non-partition tables, really important to our database. And in a traditional database, these are just regular tables. And you're probably asking yourself, okay, well, how does this work in a sharded database? I need this data for my application. How do you deal with these in our sharded database? Where do they go? Do they sit on one of these databases, and then APAC EU and North America try to communicate with APAC to get this? And what happens if APAC goes down? Where do we store this data here? Well, in sharded databases, we deal with this with a concept called a duplicated table. These are duplicated. This data is duplicated into each of the databases as a materialized view. And so you're probably still asking, well, duplicated from where? And the answer is the shard catalog database. So the catalog houses the duplicated tables, and it also houses their data. So just like we perform all of our DML transactions on the shard catalog, and we propagate that across to our shard databases, we house our low volatility common table data in these duplicated tables in the shard catalog. And the duplicated tables are replicated out as materialized views into each of the shard databases on a regular basis. I think the default is that it pushes this data every 60 seconds, but you have the capability of tuning that if you would like. So now we have this geographically distributed database. We have live data for each of our regions. We have materialized views that are satisfying our need to maintain that duplicated, low volatility, or non-partitioned or non-sharded data. Let's look real quickly here at how clients connect to our shard databases. Because you're probably asking yourself, okay, well, this is great. If I connect to the North America database and I need data from Asia Pacific, is that going to be a really long hop or multiple hops, things like that? And the answer is that all of our client connections are handled through connection pools, and then also shard directors, primarily connection pools. So your client is going to connect to a connection pool, and that connection pool acts like a listener for the shard database as a whole. So that connection pool says, I'm aware of all of my locations, all of my database shards. And when the client connects, it connects in a way that it passes a sharding key. And if the sharding key is already cached in the connection pool, so our connection pool, let's say, already has our APAC key cached in it, then this client asking for an APAC record is going to be directed down here to our APAC database. Now, if for some reason the connection pool doesn't have the sharding key for the EU region, it's going to connect here. The connection pool is going to say, I don't know where this key belongs. So it's going to communicate with the shard director, and the shard director is going to pass this information back to the connection pool, and the connection pool can establish the connection. Now, this concept of caching sharding keys and so forth is really more relevant to system managed sharding, where we have this consistent hash. And it's mainly because the hash can be split and changed so that you can increase the number of shards underlying it. This really isn't a huge concern for us when we're dealing with user managed sharding, because you're dealing with such a limited, or typically you're going to deal with such a limited set of either values or ranges that on startup, these connection pools are going to get the information that it needs from the shard directors. So once you have all of your shard keys cached into your connection pool, this shard director can go offline, and it won't affect any sort of connectivity. It won't affect your client's ability to access the application or the database by any means. And of course, the pools and the shard directors can all be configured. And in fact, Oracle recommends that they're configured as redundant distributed mechanisms. Now, the final piece of this architecture is maintaining the durability of our shards. All of these shards are protected. Oracle recommends that they're protected with active data guard. Now, there are cases where you can use Golden Gate for protecting your shards, but they're a little bit more limited. So primarily, your protection mechanism is going to be data guard. Sharding is part of the maximum availability architecture, as I mentioned, and it's primarily marketed as a high availability and performance feature. And what's cool about that is that when you're setting up sharding, when you say, I want to add this new region, I want to call it APAC, sharding and the shard, it's not really, I was going to say it's a sharding wizard, but it's not really a wizard. It's not quite that easy. But when you're setting up that shard, you have the ability of saying, I want this to be protected by active data guard. And the sharding configuration process will not only build out this first shard database for you, but it'll also automatically configure the data guard standby, as well as setting up data guard broker so that you have active failover or fast failover for those data guard replicas. So let's put all this together. If we're going to follow best practices, we have our catalog database. We have a catalog database that's protected by active data guard, preferably in a different region. We have multiple shards for our database, and each of those shards is protected by active data guard. We have shard directors that can be part of the catalog database. They can be part of the, or hosted with individual shards if you'd like. And then we have connection pools that don't necessarily have to be associated with anything. They can just be a connection pool regionally, or they can be co-located with a database. And this is what your sharding deployment might look like for your global deployment. So there's a lot of flexibility when it comes to building out sharding architecture. And my recommendation to you is to take a conservative and cautious approach. Now, I said that this is based on very mature technology, that it's based on Oracle partitioning, and that partitioning has been around for a long time, and you should be confident in it, that it's not something new. That said, my recommendation is work with the latest versions, work with the 19C, work with 20C or 21C when they're released. They're going to be easier for you to work with. They introduce features that make sharding more practical for a wider range of applications, and they're more stable. And they're also going to be easier for you to work with as an administrator. And although you can configure a sharded database to use either non-container or multi-tenant databases as of 18C. So you can have sharding working with a container database, and as pluggables, you can have multiple pluggable databases in a CDB that are shards as of database 19C. Your shards can be rack, they can be single instance, they can sit in the cloud, they can be in your data center, it can be a hybrid. The storage on those individual databases, remember that this is a set of individual databases, so the way that data is stored locally on each of those is transparent to all of the other nodes, so you can have a mix of ASM and disk and so forth. And you can even mix versions. So I could set up a shard database that runs on 19C, and I can have a 12C shard, and I can have an 18C shard. The limitation of that is that my 19C database will only have shard version or shard features available to me that are also available in my lowest version. So I could only use the 12C versions of sharding, or 12C features of sharding, in my 19C database, because we've got to have that feature compatibility across the top. So you have a lot of flexibility when it comes to designing your database. I mean, you can have all this, you can have rack over here and single instance over there, and 12C on in APAC, and 19C in the EU and so forth. My recommendation to you is to keep it as simple as possible. Because like I was saying, while this is partitioning and it's a very mature technology, it's also sharding, and it doesn't yet have really widespread adoption. And as such, it's not tremendously well documented by Oracle. There are some areas in the documentation that are contradictory. There is some documentation that just appears to be incorrect. So just because Oracle says that you can mix and match these various components, it's unlikely that much of that mixing and matching is proven with any robust testing in practice. So I would say that just because you can doesn't mean that you should, and is probably some good advice for you to follow in this case. So that's sharding. And if you've missed the reference, this is from the movie Anyway, it's from a movie where we use this line, "I just sharded," and I can't talk about sharding to my wife without her giggling just a little tiny bit. So I have a sharding lab that you are able to download off of GitHub that will run a sharded database for you in Docker. It builds 4 Oracle 19c databases in 4 separate database containers. All of the containers, all of the databases rather, are multi-tenant, and it builds up the shards as the names of the hosts. And you get pluggable databases in each. And this will let you get in and play with sharding if you would like it. It adds a pre-configured database with the North America, Europe, and Asia Pacific databases. Along Came Polly is the movie, I beg your pardon. So if you want to experiment with it, this is a neat way of getting into learning about sharding and maybe building out some use cases that you can demonstrate to your management or to your development teams so that they can start to understand how sharding works and whether or not it is something that is applicable to your business needs and use cases. And all of that is on my GitHub here at github.com, Oracle Sean, and the repo is the Oracle SDB repo. It's a cool little, fun little lab to play with if you want to get some experience with sharding. And you can certainly extend it into becoming composite shard keys or to use a system managed sharding if you would like. And that does it. That's the introduction to sharding for you. Thank you everybody for attending, and thanks for hosting the event. I hope that everyone found this to be worthwhile. Are there any questions? Anybody?
Oh, checking here, I don't see any. So if anybody has any questions, just feel free to enter them in the QA.
Either I put everybody to sleep, or everyone's this is not for me, or it's just the end of the day and you all went home.
I don't know. Yeah, probably maybe a combination of everything.